Let's talk about wavelength of a periodic wave. The wavelength is the word used to describe the physical size of one whole assault of a periodic wave. So that means that I got to go from one place where the periodic wave is doing something to another place where the periodic wave is doing the same thing. All right? So we can think of it as the distance between two consecutive peaks or two consecutive troughs. One easy way to think about this is that if you're sitting on a boat in the ocean and you're at a peak in an ocean wave and you look down to where the next peak is, the distance to that is the wavelength. So if I've got a periodic wave here, the wavelength is the distance between two peaks or the distance between two troughs. But that's not the only way that I could do it. I could also say, well, geez, here the wave's doing something. Wave's doing the same thing there. So that has to be the wavelength also. All right? Now notice that it's not just where the wave is in the same place, because this distance is certainly not a wavelength. So it's got to be in the same place doing the same thing. And then you get a wavelength. Now, what's this weird symbol I'm using for wavelength? This is a Greek letter lambda. And we write a lambda like this. It's real simple. Backslash, forward slash. There you go, lambda. All right, so let's talk about some problems that I've seen on tests asking about wavelength. So suppose that we're given a wave, a periodic wave like this, and we've got some points labeled, all right? And we're asked to find the wavelength given a bunch of different situations. All right, so let's look at the first one. A to E is 6 meters, A to E. All right, so what we've got to do is figure out how many wavelengths appear between A and E. All right, well, I start at A, and here I go. Well, that's a whole wave, because I started off at A, and C is doing the same thing. So that's a whole wave. And then I got another whole wave. So if this is 2 waves, and the distance is 6, then that means 2 lambda must equal 6. So lambda is 3 meters. Does that make sense? Not difficult at all. All right, how about A to C? Well, it is. A to C is a wavelength. So that tells us the answer immediately. 5 meters. All right, what about this next one? A to B is 4 meters. Well, A to B right here looks like half a wavelength because the piece here and the piece here are the same, just inverted. All right? So that means that 1/2 of the wavelength will be 4, and that means that the wavelength will be 8 meters. All right, now this one's the most difficult one. Still not that bad, but it is the most difficult. A to D is 8 meters. All right, A to D. How much of a wavelength is that? Well, I've got a whole wave here from A to C, and then I've got another half of a wave from C to D. So that means that I've got 1/2 or 3/2 wavelength, and that's going to be given by 8 meters. So that means that the wavelength in this case is 16/3 of a meter. Now that's one, probably the only of these 4, that you'd probably really need to write down. All right, that you actually would have to write it down. And that's why I wanted to do it, because these aren't always so simple that you can just look and guess the answer. All right, now I just want to say a couple of words about what wavelength means. We said over there that wavelength is the characteristic size of a wave. But what does that mean? Why do I care? Well, if I'm on a ship, I care very much. Because let's say that the ocean wave looks like this. Okay, there's my ocean wave. Now, what if my ship is much smaller than a wavelength? So my ship is right here. Great. I don't care about that wave. The wave's doing essentially the same thing the whole time underneath me. So I don't really care. I'll just go up and down with the wave and I'm fine. Right? All right. What if my ship is much bigger than the wavelength? Well, geez. Now the wave is kind of just averaging out underneath my ship. All right, so again, it doesn't really matter that much. But what if the wave and the ship are about the same size? Well, now I'm going to have one part of my ship here and the other part here. And now my ship's going to break. So that's the idea. Wavelength is the physical size of the wave. It's the characteristic size. And whenever we're doing problems involving waves, we want to be very, very, very careful when we're looking at the interaction between a wave and some physical object whose size is around the same as the wavelength of that wave. All right, and there's wavelength.